From ContainerDays Hamburg, this video is proudly presented by Dux IT.
So, I do realize we talk a lot about AI agents. I think the previous talk in this same room was about AI agents on Google Cloud. So I'd love to first hear a little bit about you. So who here has been using AI agents? Okay, and who have built AI agents? Okay, a bit less hands. And who have deployed AI agents in production? Okay, even less hands, right? So we're probably left with 3 to 5 hands. Okay, so some of you already know what that stuff I'm talking about is, and some of you maybe already experienced the problems that we're attempting to solve right now, right? But anyway, I'm going to explain it all in simplest terms, hopefully. But the first thing I want to say is that the title of my talk is kind of bullshit, because Kubernetes has always been agentic. And you know why? Because who can tell me what an agent actually is? Anybody? Don't be shy. Okay. Yeah, I know German folks don't speak up too much. And that's fine. So Kubernetes has always been agentic. But basically an agent, and I think you know it, you're just too shy to talk about it. So an agent is basically an entity, which could be, you know, a person, or an animal, or a robot, or maybe a person and a robot at the same time. Think Agent Smith, right? That acts on our behalf. So, in unserem Namen. Yeah? And also, hopefully, takes decisions automatically and autonomously, but these decisions are aligned with what it could be me personally, or maybe an organization, a group I'm a member of, what we expect it to do. Yeah? Hopefully, it acts in our best interest. Now, I think when we talk about agents specifically in IT and software, it's very important to make this distinction between a tool and an agent, because it's basically that distinction between the imperative and the declarative mode of operation, right? So with a tool, we need to continuously issue commands. Each step of the way, if we want to arrive somewhere, we need to tell the tool what to do. But with agent, again, we expect it to be smart enough so that we can declare the goal. This is what I want to have. This is what I want to be done. And then the agent will probably be smart enough and aligned enough with our best interest to take the decisions automatically to get us there, right? And by the way, do you know what that entity is called? Yeah, you now know. That entity that the agent acts on behalf of is called the principal. So once you start using agents, and some of you said you already do, you become principals. So congrats, you're now a principal. And actually in psychoeconomics, there is even a known problem that is called the agent-principal problem, that talks about the fact that sometimes, and maybe in many cases, the agent is expected to act in our best interest, but it doesn't always do. Think politicians, for example, right? And it is also called the cost of agency. And we're not talking about, you know, what you're paying to OpenAI or Anthropic here, but definitely this problem becomes even more relevant now that we have AI agents that we expect to act in our best interest. Now, back to Kubernetes. Why am I saying that Kubernetes has always been agentic? Because basically, that declarative mode of operation is how Kubernetes works, right? We declare what the desired state of the cluster is, and Kubernetes controllers as our faithful agents, they run those control loops and try to make sure that our desired state becomes the actual state of the cluster. And then they continue to check the actual state, and if something diverges from the desired state, they try to make sure that the desired state is the actual state and vice versa. And of course, at the end of this path, there's also the kubelet, which is the Kubernetes agent running on each one of the nodes, making sure that all of the containers we want running are actually running. So yes, in that respect, Kubernetes has always been agentic. And I think another distinction, because we're not here to talk about how Kubernetes has always been agentic and it's all fine and we can all go home, right? We're here to talk about AI agents. So how are AI agents different? So basically, most comparisons, and I just compared an agent to a tool, but most comparisons when you talk about AI, they compare them to AI chatbots, saying that a chatbot basically can only answer questions, provide instructions, guidelines, information, while an AI agent can do stuff for us. Now, we just saw that the agent of the old times, Kubernetes controllers, could also do stuff. So how are they different? Well, basically, the agents of the old times were just stupid, deterministic, finite state machines that only had a predefined set of states they could take care of, while with LLMs, everything becomes much more exciting and unexpected, right? So that state matrix extends into infinity, and hopefully, the AI agents takes correct decisions, but these decisions and these actions are only statistically predictable. So when I get asked if AI agents will make us more productive and let us achieve better results, I will say not necessarily. But if I get asked if AI agents will make our work more exciting and adventurous, I will say yes, sir, or yes, ma'am. Depends on who's asking, yeah? Depends on the prompt. So this is a good spot to say a few words about me. So I'm Ant, or Anton Weiss, and I'm here as the agent of a company called Perfect Scale. So Kubernetes is already agentic, as we saw. It's very smart, but it can also get very costly, and not necessarily all of our workloads will be as performant and as available and reliable as we want them. So what Perfect Scale does, it provides a platform that allows you to make sure all your workloads on Kubernetes are as reliable as possible while keeping them at the lowest possible cost. So definitely check it out. And yeah, this is QR code is for my LinkedIn profile. Definitely let's get connected. If you have questions about the project that I'm going to present to you in a minute. But before that, back to AI agents. That's the thing that's buzzing, right? So in the simplest term, an AI agent is just an ape with machine guns, right? Just kidding. It's basically an LLM with tools that allow us to act on our behalf, to take actions, to run commands, right? But it also has an identity. Some folks call it the brain of the agent. So basically, that's the system prompt that defines what that agent does, how it acts, what defines its actions, that creates that alignment. And it also has, in many cases, also a memory, which, first of all, is the context of the current conversation, but also optionally previous conversations we had, and also maybe some organizational guidelines it has access to, stuff like that. Okay, now how do we provide our agent with tools? Here's an example of how this can be done in its simplest form. So this is the code for a framework called ADK. Has anybody here used ADK? Heard about ADK? Okay, so ADK is the Agent Development Kit, a framework provided by Google. Very easy, simple Python code. We have two functions here. One of them is called kubectl, calls kubectl. Another one is just simple call shell. And then we wrap them in function tool, and then that is given to the agent definition. And that basically causes the agent pass those to the LLM when we provide queries, and then the LLM knows that it can call those tools in order to retrieve information and change the state of whatever we're talking about. Now, this, of course, is not the best way to provide tools because it's static, it's there in the agent code. We want to provide new tools, we need to rewrite the agent, rebuild the agent, redeploy the agent. We want dynamic loading, right? And that's a place to talk about the thing that seems to be buzzing not less than AI agent, and that's, of course, MCP. MCP is a protocol that was defined by the folks at Anthropic. It's a model context protocol, and it allows us to wrap our tooling in that abstraction layer that allows the LLMs to discover the tools that are exposed, and also that layer allows to add whatever is needed, for enterprise tool utilization, stuff like authorization, authentication. And yeah, it allows for dynamic tool loading. So basically, the agent that's running has the MCP servers in its context, and it can go to those MCP servers. It can ask whatever tools are available and then use those tools in its queries. And of course, MCP servers can be redeployed, so the list of tools can grow or shrink, and that gives our LLMs access to potentially complex workflows, API calls, whatever we need it to access. Now, once we deploy an agent, we also don't want it to feel alone, right? Because it can potentially use not only tools, but also other agents that can help it with the work that it's doing on our behalf. And that's where the A2A protocol, also developed by Google, comes into play, which allows one agent to discover other agents' capabilities. Then agents can talk to one another to negotiate the modes in which they operate. They can communicate with text, voice, video. They can securely collaborate on long-running tasks, keeping the contents, the mutual context. And finally, they do all that without exposing their internal states and memory. So it's also pretty secure, right? Well, getting there at least. Now, why am I talking about all this? Because we now see that there are already a number of moving parts. There's the agent itself, there are the MCP servers, there's the A2A protocol, potentially other stuff that we haven't talked about. Now, if you want to take all that and deploy it on Kubernetes, is there a simple, easy, and fun way? There was none, and now there is. So let me present you Kagent, which is a fairly young open source project. It was built by the talented folks at a company named Solo.io, and it gives us a Kubernetes native framework for deploying, running, orchestrating AI agents. It supports multiple LLMs. It has, of course, as I said, built-in MCP integration, built-in A2A integration. It provides us with the engine that allows us to run agents, and then it also gives us a nice CLI and a great UI dashboard that we'll see in a moment, and of course the controller that continuously acts on our behalf by making sure all our agents are configured as we expect them to be. So how does this work? A little bit of code, because you're tech folks here, hopefully. So this is how you define an agent in Kagent. This agent is called a DevOps assistant. It has a system prompt that defines that it's a senior DevOps engineer. It should be helpful, but never delete production data. And ask for confirmation when in doubt. So LLMs can be in doubt. Now, it also has access to tools exposed as one of them is exposed, an MCP server exposed as a Kubernetes service, and another one is exposed as a remote MCP server, which is another custom resource defined by Kagent that we'll see in a moment. But before that, it also defines a model config up there, which is defined as a default model config. So you can have multiple model configs in your cluster. This specific model config you can see here is talking about a model exposed by OpenAI. It's a GPT-4.1 mini. And of course, you'll need an API key to access that. And finally, how do you define an MCP server? So here is, it's called a remote MCP server because it's accessed by streamable HTTP. This is how the official Kagent tool server that comes built in with Kagent that provides access to many Kubernetes tools. This is how it's defined. You need to define the URL to find it at. And finally, in the status of that CR, you can see all of its discovered tools. The list is much longer. I'm confined by the size of the slide. So yeah, we're only showing a few tools here. The actual list is about a few dozen tools long. Okay, demo. Let's pray to demo gods. What does this look like in real life? Okay, so I have Kagent running. Let's see that it's still running, right? So this is Kagent deployed on my cluster. Okay, if I jump here, you can see that I'm port forwarding to the Kagent service. And if I do kubectl get pod -n, oh, Kagent, oh, Kagent, thank you. No, that's, second. Okay, yeah, this. Okay, these are all the Kagent pods. We can see those are the agents that are running. There is a Helm agent, the Kubernetes agent, the Kagent controller. There is a Grafana MCP deployed by Kagent. And here's the Kagent MCP server called Kagent Tools. So each one of them creates a deployment. And then there's the Kagent UI that we're going to look at. And here it is. And here's the Kagent Kubernetes agent. We'll talk to that one. In the agent details, you see all of the tools it has access to. And of course, you can tell it, show me all the pods in namespace perfect scale, for example. Let's see if it does that. So you can see it starts running its tools. Specifically here, it's Kubernetes get resources. And then it comes back to me and says, here are all the pods in the namespace perfect scale. There is the perfect scale exporter and perfect scale cube state metrics. And that's exactly what perfect scale is running in order to get your cluster performance and cost data. Okay, very short demo. It can do but it worked, right? So basically, yeah, this sent a request to OpenAI. It said, here are the tools you have access to. The LLM came back to the agent saying, call the Kubernetes get resources tool for me. It called the Kubernetes get resources, returned the list of the resources back to the LLM, and then it processed them and gave us this nice text that we saw. Okay, so what is still missing? Now, as I said, agents are entities that we expect to act on our behalf. As you just saw in Kagent, in its initial form, if you wanted to summon an agent, you needed to chat to it, as if it was just a chatbot, right? In my mind, an agent should be acting on my behalf even when I'm not there, even when I'm not talking to it. Hopefully when I'm asleep or when I'm sitting on the beach sipping my pina colada. So I want my agents to be reactive. I want them to be event-driven. I want them to react to events that are occurring. And of course, I want these reactions to be aligned with whatever strategy I'm defining. And that's why when I started playing with Kagent 2 months ago, I was initially very excited, but then I started feeling that something's missing. And that autonomy, that reactivity, that magic that I wanted the agents to have, I built it myself. And here I present to you a sub-project of Kagent that was just added to Kagent organization last week, and it's called Khook. It allows us to create reactive, event-driven agent workflows. So this is the way it works. Here is the diagram. So we have a hook CRD. We'll see it in a moment. And a lot of stuff there to do the event deduplication, to make sure we're not sending multiple requests, and managing what events we've already reacted to, what we haven't. But in the end, we're talking to Kagent platform and calling the agents that are defined there in Kagent. So here's what it looks like. This is a hook. It's called pod monitoring hook. It can react to events such as pod restart, and there could be additional event configurations defined. For each event, we can define which agent to send the request to, what prompt to provide to that agent. And here you can see that the prompt here is insisting on autonomous mode, because this is a hook. We don't want our agent to provide answers. We want it to act. We want it to resolve an incident in the best possible way. Now, I'm not going to demo Khook right now. The environment is not fully prepared, and also I did a few changes to my local environment. But you can, if you go to my LinkedIn profile, there will be a link to a post there, and it has a YouTube video that shows what Khook looks like and how it works. So the agent's decisions and actions, as we said, are only statistically predictable. So it's a lot of fun. Definitely recommend you to try it. Now, as I said, Kagent is a fairly young OSS project. It has a lot of work still to be done, stuff like, security, authorization, authentication. Some of that is being built, some of that is on the roadmap. So definitely, if you're looking for a fun, buzzing open source project to contribute to, go to kagent.dev, join the community. There's the QR code to the Kagent Discord. It's a very welcoming community. So I wrote Khook 2 weeks ago. Then a week and a half ago, I presented it at a community meeting, and it was met with a lot of excitement. And today, it's already a part of the Kagent dev organization. So that's how fast things happen there, because it's really developing very, very fast. And this is the Khook itself, already in the Kagent dev organization. And I'll be happy to take your questions now. That was me.
At the end of the demo, the agent suggested that you can also view pod logs. How do you protect yourself against prompt injection, like hijacking your cluster?
So as I said, stuff like security, again, Kagent is very young. Right now, it's just a framework for executing agents. Whatever agents allow us to do, that's what Kagent allows us to do. Definitely we'll be introducing stuff like security and much more authorization. Right now, for example, the Kagent API is just openly accessible by anyone. It's listening on the A2A protocol, but it's not authorized or authenticated. So definitely all of those layers will need to be built in. Currently, there is no protection.
And I would say it's open source, so everyone can contribute.
Exactly, it's an open source. If you want to contribute that security layer, definitely it will be more than welcomed.
Perfect. Does Kagent also support self-hosted LLMs in their model config?
Yep. As I said in the beginning of the talk, yes, it supports any model deployed on a Llama, and it does work. So, yeah. I'm going to, by the way, This talk was originally supposed to be a workshop. In the end, it's a talk, but the workshop is still going to happen online probably, and it will include deploying an Olama-based open source model. So definitely watch my LinkedIn profile. Will announce that, and you're welcome to join.
The next question is, what was the shortest time Khook took during a test to completely destroy your cluster?
Well, it hasn't happened yet. Again, it specifically reacts to specific events. The ones I tested it with is out-of-memory kills and pod restarts, and with that, I haven't seen any attempts to destroy the cluster. It did some weird things to try to fix my restarting pods, but never thought about deleting the cluster altogether.
Probably the next question is related to that. Would you really enable Kagent in production?
First of all, I know of folks who are already running Kagent in production. Again, you can limit, for example, you cannot protect against prompt injection, but you can definitely limit the tools that you're using. So for example, if you're only provided with read-only tools, stuff like get and read, but not create and delete, then it's definitely safe to run it in production.
Perfect, thank you. How can we combine Kagent with GitOps? Most clusters run under Argo CD or Flux.
You can add a GitHub, GitLab, whatever you're using MCP, and then Kagent, instead of fixing stuff directly in the cluster, can create pull requests in your Git repositories.
That sounds
so
great.
Just give it that knowledge, give it the tools, and it will hopefully act in your best interest, as it says. Hopefully.
Nice talk. How to prevent write access or tools which would be able to change something.
Well, again, this is a question of policy. So, things that come to mind have something OPA, Kyverno, whatever, that defines what can be put inside the MCP servers or agent definitions, which tools the agent can have access to. Make sure those tools are not write tools. Right now, by the way, there is no way to define which tools are destructive and which are not, and maybe that's also a good thought. Maybe there should be some way for an MCP server, when it exposes a tool, to define which level of destructivity it has.
Very good idea. Is the list of event types extensible for Khook?
Well, it's just code, so yes, definitely anything is extensible, and it's open source, so you can clone the repo and extend it wherever you want. Right now, it's in the code. We may think of making it configurable, maybe outside of the code in some config file further on, but yeah, right now it's by extending the code.
And the last question is around in which user context identity is Kagent running? For example, which Kubernetes permissions apply?
Well, Kagent itself is just a framework for deploying agents. End of the day, the agents are doing whatever they need to do. So the Kubernetes agent and the Helm agent that we see inside Kagent definitely need all of the permissions. So Kubernetes agent, in order to run those write operations, create, delete operations, definitely needs to have a very high level of permissions. You can definitely limit that too, so that it can only act on certain namespace and not other namespace, and then it will just try to use the tools and it will fail to use the tools, and try to work around that. Hopefully not by changing roles and policies. But what I wanted to say is, yeah, those are the Kubernetes permissions that apply. They apply to agents, not Kagent itself.
A new question just came in. It's a silent time bomb, so we need RBACs for that, else it can cause production downtime, probably.
Well, you could say, in the end of the day, right, we expect AI agents to act on our behalf. In the same way, you can say that a human operator is a silent time bomb, or maybe not that silent. So if you rely on yourself to have access to the cluster, why not to rely on an AI agent to have access to the cluster once you have all the necessary guardrails in place?
Okay, then thanks a lot for answering all the amazing questions, and enjoy your lunch.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.